So welcome to DV Club. My name is Mike Barker from PBS. My topic today is UVM methodology to another step forward. This is a primer for UVM-1.2, basically describing the changes that have been made from 1.1 to 1.2. It's very much an overview of what those changes are. There's a lot of detail in 1.1 to 1.2, which we won't cover all the details today. We'll give you some idea of what's changing. Also, we have a paper which you can read afterwards, which has a lot more detail in. And also, obviously, you can go to the UVM website, the external website, and pick up the details there. Okay. This talk, you can see various names on the slide here. Roland Wang and Yuri Sim of Cadence wrote this paper, and they delivered it to previous DV Club in China, and they've given me permission to repeat the presentation here. So we must thank both Roman and Yuri for writing this paper. Okay. Before we start, just asking the audience, who is currently using UVM? So just for the people on the webinar, there's about 20 people in the audience, and I think about 5 coming up. And maybe there's more, but people are shy. I don't know. But there's at least 5 users in the audience. And what version of UVM are you using? 1.1. Everyone 1.1 as well. So every current user in the audience is 1.1 by the looks of it. Okay. So so this talk is about how you can transition from 1.1 to 1.2. So we'll carry on now. So the 1.2 primer. So for those who haven't currently moved to UVM, and I know our second speaker, and will talk about reasons for moving to UVM. So why do you use UVM? Well, you can see from this picture here the way UVM is structured. So we have underlying all this is an IEEE compliant simulator. Okay. Now, most of the market will be using either Mentor, Synopsys, or Cadence for that, and some of the market uses LDEC as well, and maybe more on the FPGA side than the ASIC side. How many people here are FPGA? Is everyone ASIC? ASIC? Okay. I think most of the audience is ASIC. But as I say, FPGA people, there are some FPGA people that are starting to use UVM as well. But most of the UVM audience is ASIC rather than FPGA, and most of them are either Mentor, Cadence, or Synopsys, and the same with Fuel and LDEC as well that we know about. So you have a simulator, and what you get on top of that is a set of class libraries and utilities. That's the UVM deliverable. It's a set of source code which can be run on top of the simulator. So it's just open source code. On top of that, there's some methodology documentation examples and code snippets which you try to explain to you how to build a UVM environment. I think some of that documentation methodology is about 1,500 pages long, and there's many ways to build a UVM environment. I think if you ask 2 people to build a UVM environment for the same protocol, they'd probably do it in different ways. So there's no real standard way of doing UVM. There's always slight variations that people take in the way they build their test benches. And on top of this now, there's an ecosystem which has been set up really around UVM, which allows people to share verification IP, share verification environments, maybe also go to the market and buy verification IP. Okay. So, for example, Cadence, Synopsys, Mentor all sell verification IP as does TDF as well. So there's quite a big market verification IP which can accelerate your project together, all of the simulator vendors into one environment. Now that has a big impact because we can easily now move between vendors, so you're no longer trapped into a particular vendor. So before, if you were using SpecMan, you were probably trapped into Cadence. If you're using VMM, you're probably trapped into, you can buy training, you go in the market, you can buy VIP. Okay. So the ecosystem allows us to be a lot more efficient and effective in our verification. So UVM isn't just a set of class libraries which allow you to build test benches more easily, more quickly. You should see UVM as a complete ecosystem which allows you to be more effective, more strategic in your verification. So what we're going to talk about today is what's changed from 1.1 to 1.2, some of the migration challenges that you'll see along the way, and because this is a Cadence paper as well, I'm going to talk a little bit about Cadence inside the UVM solution. So they're the three main topics we'll be talking about. So here's a brief history of UVM, if you like. You'll see here that we've gone from 1.0 to 1.1, 1.1 A, B, C, and D, and now then to 1.2. Okay. 1.2 you'll see is mainly focused on fixes, message debug infrastructure, and phase array sequences, but I'll go into more detail as exactly what's in 1.1, it's in 1.2. You should look at UVM 1.1, which introduces this concept of UVM node deprecated. That allows you effectively to run your simulation environment with the deprecated features turned off. Okay, now if you're porting from one version of UVM to the next version of UVM, running with UVM node deprecated is quite a good idea to see what's going to happen to you when things get deprecated. So it's a good way of future-proofing your UVM environment to make sure you're not relying on being attacked. You're not relying on features which are going to be deprecated in the future. Okay. So that's a very useful thing to consider. Okay. Right, so we're going to now look a little more detail into the 1.2 features that are coming up. Okay. So there's a lot that goes into UVM before you see it. This is if you like, the standard committee approach. I work on the E standard, the E language standard, and we do a similar thing as we're going on UVM here. Okay. So there's a working group who are working on the changes that are going to UVM. Okay. And I think there's always space for people to join the working group if you want and influence the future direction of UVM. That's the way it works. You have a working group who are the engineers deeply involved in using UVM or writing UVM, which allows them to bring the new features which they want in the next version of UVM 1.2. That gets approved by the working group, moves to the external board, which then also approves those changes. Okay. Then goes to an editor, and that editor then got the right documentation so that when you make the release, all the documentation is in place. So everything's ready for the user community to start using it. Okay. You can see here the timeline for this as well. So it went to the editor in April, and it's going to be released very, very shortly. Everything's been approved now. You also see on this timeline IEEE. At the moment, I think the IEEE is not been decided whether it's going to become an IEEE standard or it's still an accelerator standard. So on the right-hand side of this slide, you can see some of the changes that have gone on, and these are the ones we're going to talk about in these slides: bug fixes, the enhancements. Now, that third bullet under what to expect, the few API and semantic changes, this is the one that should worry you most, because the API changes, the semantic changes, means 1.2 is not backwards compatible to 1.1. Okay? So that means if you go to 1.2, you're not backwards compatible to 1.1, and that's because those API changes and the semantic changes. Okay? So we'll talk about the things that stop it being backwards compatible as we go. And then about 50% of the changes are API changes, and 25% from the backwards compatibility. Okay, so that's something to be concerned about. As I said, the IEEE will take about 6 months to 1 year to release the standard. But that doesn't really bother us because we know it's an XLR standard and we're going to be getting it soon. Okay. Okay, so these are the details we're going to be talking about during the talk. Reporting its structure, sequence, registers, objects, phasing, considering database factory, objections, events, transaction recordings, and some miscellaneous items. There's a lot of detail, and we won't go into the detail during the talk. Okay. The PDF of the slides is available afterwards, and also there's a more detailed paper written by Bowman and Julie Shim of Cadence. In fact, both of those will be available afterwards. You can go into detail afterwards, and you can also go to the UVM website. So this is just a quick skim of what to expect. Okay, so the first one is on reporting. It's now become object-based, which allows us to add values objects to record registry and to our messages. So you can see the code snippet here is an example where they're adding a tag of my color and the color red to the message. So because our messages are object-based, you can start to add values and objects to them. Okay, and also you can record messages to some storage here. It's this type here, this class here, called the TextTL database, transaction database. It's a virtual class which hides the actual EDA implementation of the transaction database, which allows you to put information on top of the waves. As you can see on the right hand side here, that means all dollar display calls, which were mostly left to debug out now, have been routed to UVM messaging rather than dollar display, so they all appear on our place. Okay. Then there's new add-on, map. The message map is the one you'd expect at UVM style beginning, UVM style. Okay. So the reporting has changed, it's become object-based, allows you to have values and objects, and record messages to other storage. Okay. Sequences changes. So you are now able to perform a raise drop of an objection before and after the sequence execution. Okay. Through automatic phase objection. So if you can see here, in this constructor here, we're setting up an automatic phase objection, which allows us to automatically do raise and drop of objections on the sequence execution. Okay. There's also allows us here, this is a command line option on both two UVM sequence command line option. Allows us to set up the defaults. Now, speaking to Roman about this, as I say, Roman of A&D wrote this paper, and they've been using 1.2, been trialing it on some of the block rather than SOC, and we'll speak about why he started at block rather than moving to SOC. We'll speak about that later in the presentation. But he says this can be useful, for example, when you've got a slave and you just want that slave to have a default sequence so it can respond to transactions it's receiving. Normally, when you're trying to run an environment, you're going to look for more interaction with the sequence rather than just have a default sequence. But quite often, he says they've used it in an environment where they've had a memory model and the slave is just responding to transactions, and you can set up a default sequence which allows you to do that. So there's only a few situations where default sequence is useful, and you can set that up in the command line. And this sorry. I think you can do that for for multiple sequences, for agents, you mean? Yeah. I think so. I haven't. Starting phase is now guarded. Okay, and you'll see this later on as well. There's been a lot more access control, data access control, and there's data access policies. So you'll see that they're setting up more data access policies, which allow you're using get and set more often than just directly accessing variables. So they're starting to guard variables. Okay, registers. Yeah, so what would, you'll see later that there's another slide on data access policies. So it's a policy about how you access variables effectively in a multi-threaded environment, and you want to protect variables against particular types of access. Okay. So we've all been using registers and the register abstraction layers and register modeling for a long time. Unfortunately, our VHDL community has been locked out of backdoor support. So VHDL backdoor support is now added. Also, there's this example here. So this example here allows us to control the transaction order policy. So let's just look at an example here. Imagine we've got a DU2 register which is 32 bits wide, but it's sat on a bus which is 16-bit wide. Okay, so when we want to write to that register, that's going to result in two transactions. Okay, two 16-bit transactions on the bus is going to update our 32-bit register. Okay, what you want to be able to do, or what people want to be able to do, is control the order of those transactions. Okay, playing into big Indian or little Indian, for example. Okay, so that's that is now built in, so that you can actually now update according to a policy. Okay, by ordering those transactions, the order of those transactions. So, for example, you might want to do the lower address first and the higher address second, depending for a big Indian or little Indian. Okay, so that's been added to the registers. In the past, UVM objects did not always require a constructor. Okay, that's really considered bad programming style to not have a constructor on an object or on a class. So now it's enforced. So this is a change which is not backwards compatible. Okay, so if you're sat inside 1.1 and you have objects with no, or classes with no constructors, okay, then you can run that in 1.1, but you will not be able to run that in 1.2 unless you set this macro, UVM object do not need constructor. Okay, so that's a way of getting around it for now, but I think the idea here is that you should try to move all your classes to be 1.2 compliant, which means that you have to have constructors. Component names are being checked for compliance, so this is just basically, again, tidying up, trying to make our coding style more software engineering like, if you like. That's better coding style for the way we write our UVM code. Okay, so in trying to stop you writing bad names, this will be picked up by a linter and stopped at compile time. There's a new type as well called integral, UVM integral T underscore T. This is 64 packed logic. I'm told, I haven't used this type, but I'm told it's in there because up to now I think it had to be 124 bytes. So this is basically allowing you to do more memory efficient by allowing you to have 64 bits rather than 1024 bits. Okay. So that's just a memory saving new type they introduced for memory saving. Okay. Phasing. Before you could have objections being raised and dropped on non-time consuming functions. Okay. We decided that didn't make any sense, and I agree with that. You know, if you're doing non-time consuming stuff, you shouldn't be doing raise and drop objections on that. So that's been removed, the ability to do that. So all for example, function failures have been dropped. Also, you can get the objection count during a phase as well. And if you're in phase transitions, we can now do a callback during a phase transition as well. So you can see the code here that's detecting the phase transition, and there's a callback allowed during that phase transition. Okay. So again, there's a lot of code in here, and we haven't got the time to get into the detail. We can look at the paper, either the slides afterwards or the paper afterwards, or actually then go to the 1.2 download on the Accelera website. Okay. In terms of the UVM configuration database, UVM_config_DB, meta characters and regular expressions and field names are disabled. There's two reasons for this. So if you look at the first code fragment here, you can see some of the types of things you were allowed to do. And they cause two types of issues. One is performance issues, so it's a high overhead during the searching when you've got names like that. And also, it's not always clear during that searching the semantic implications of those names, so what those names actually mean semantically. So that type of thing has now been banned or disabled. Again, it's just trying to clean up the coding style, make the coding style better. Okay. Set config style, get config style now deprecated. So if you use them within your environment, they won't work anymore. I always thought they were a little bit dangerous because we were never quite sure how big that style was when you did that search. So they've now been deprecated. There's changes in the factory. So the UVM package factory has now been removed, but you can retrieve the factory via get. So you can use the UVM factory get instead. And you can undo a factory override as well. You can replace the factory in order to trace or log factory calls or build a dynamic factory. Okay, so here you can see here somebody's building their own factory to extend the replace the current factory. Okay. Yeah. This one here? No, they're not deprecated. No, it's just on the specifically for the DB. You're asking, yeah? Yeah. I don't think so, but maybe I'll have to come back to you on that. I don't think so. Yeah, I don't know if that means all of them. So, sorry? Yeah, it's an UVM construct. So is that clear? Yeah. Okay. Yeah. Yeah, sorry, the UVM config database is still there, but this is an UVM construct which has been removed. Okay. So on objections, before, when you set and raised an objection, that used to ripple up through the hierarchy. What people noticed that had a performance hit, especially if you were doing a lot of high frequency raise and drop scenarios, and you had a deep hierarchy. Okay, and it wasn't always particularly useful to ripple it up. So you've now got a set propagate mode, which will allow you just to say only ripple up to the topmost class in the hierarchy. Okay, so you can use that to improve performance if that's actually give you performance gain. That's there just for performance reasons. I think the default is probably node 1 would be my guess, because that's the old stuff. But yeah, you probably have to look more into the documentation. I can't remember off the top of my head what the default is. Okay, so some miscellaneous changes. So this is what I was talking about earlier in terms of data access policy objects, to try and get more controlled access to embedded objects through get to lock and get and set. So there's also here a set before get, which is like the sort of equivalent of initialize before use. Okay, so you can set a data access policy to make sure that your you don't use uninitialized data effectively, or variables. This is the pattern infrastructure. I have to admit I've never used the visitor pattern infrastructure. It's a particular software engineering design pattern, which allows you to extend an existing hierarchy of classes without actually going in and changing those classes individually. If you really want to know about it, I would just look it up. I did a Wikipedia search on it, and it seems a very good way of extending existing class hierarchies without having to change each class individually. It's a very efficient way of doing that, but I would recommend, if you really want to know a lot about it, is to go away and read up on it, and then try and work out how you could potentially use that within your environment. We've got a core service singleton added. The UVM sequence library is now documented. These are just small miscellaneous things. I won't go into a lot of detail because there's quite a lot of them. UVM severity type is deprecated to an enum. So there's a new UVM enum wrapper converter, which allows you to convert from strings to enums more easily. Messages in the DPI-C interface can now be routed to the UVM messaging facilities as well. The separation of classes into abstract API and default implementations. I was desperate to get in the factory and the default server, and some other cleanup. So they're the miscellaneous ones. The paper goes into a lot more detail, but what I want to talk about is the migration challenges which you potentially will face moving from 1.1 to 1.2. So it's largely backwards compatible. What we've seen is a few examples where it's not going to be backwards compatible, and so it may not be the case for all of your projects. Okay, so we've seen a couple of situations, for example, on constructors where it's not backwards compatible. So there is a conversion script, and that's described in the next slide, but some items will still be manually need to be manually modified after that conversion script. Obviously, encrypted VIP cannot be migrated by the conversion script. The conversion script is going to work on source code only. So if you are using encrypted VIP, you've got I guess you need to go back to your supplier and ask them for a 1.2 version, from 1.1. Either that, or you use a supplier which gives you source code, which TDF does. But, so you do need to either move your encrypted VIP from 1.1 to 1.2, or obtain the source code of the VIP. 1.2 cannot be mixed with other UVM versions in one verification environment, and I think that's probably quite a big potential issue for people, because it means that you can't, as I said before, Roman of AMD has been using this at block level, because obviously at block level, you can move maybe a whole block level environment from 1.1 to 1.2. Moving a complete system SOC environment from 1.1 to 1.2 is probably a lot harder. So certainly what he's done is trialed it first on on a block level for 1.2. But that's so that fourth bullet is a big warning as well. You can't mix and match these environments, and that's because there's so many semantic differences between the two, 1.1 and 1.2. So if you're migrating from 1.1 to 1.2, the backward incompatible changes are outlined as a migration document which comes with the 1.2 release. The 1.2 release also has a list of all the addressed Mantis items with a marker for backwards compatibility as well. So you can see from that release notes what's not backwards compatible. There's migration scripts which are supplied. So you can see here, it's your, I think there's a typo there, but it's your constructors missing. You can add constructors in, and then these scripts are helping you move from UVM 1.1 to UVM 1.2. There's still the OVM to UVM in there if you're still an OVM. Okay. And this slide just tells you some of the manual interventions you might need to do as well, because not everything's going to be done by the script. Okay. So there's still some manual work you need to do. Okay. So just as some help for cadence marketing, the Incisive platform now is optimized to run UVM, and obviously here you can see the Incisive platform allows you to build the UVM environment, run the UVM environment, and then analyze the verification results, all within the Incisive verification platform. Okay, and they also provide a debug. So Cadence acquired SimVision recently, and that can be used for not only debugging waves now, but also your UVM. You have a good view of all the UVM registers. You've got all the UVM variables, etc., etc., to allow you to do improved debug of the UVM environment. Okay. So, in summary, the UVM 1.2 offers some new incremental features, mostly backwards compatible, but not completely backwards compatible. There are some migration scripts, which is reasonably straightforward to use, but doesn't do 100% of the job. There will still be some manual stuff you need to do, and then the cadence marketing. Okay, so that's it. Thank you, and thank you to Roman Wayne and Yuri Shin of AMD and Cadence respectively for the presentation, and for allowing us to repeat the presentation here. So we do have time for some questions if anyone has any questions. I think we were asking questions as we went, so I think most of them were answered. I would recommend, first of all, this slide set will be available, so you can go away and get more detail from this slide set. There's an accompanying paper written by Yuri and Roman, which you can get the details, and then go to the website as well. This paper is only really just outlined the changes. It's not a detail of every single change in there. It gives you some idea of what's coming in 1.2. Okay, thank you.